guys, we're back tripping with the Smiths blog. It's gonna be a how-to one. We are replacing our smaller inverter with a big inverter so we can supply outlets, different ones, different guys, as you can see, I don't know all this technical stuff, so hold on. We're replacing, like I said, the small with a bigger one so we can supply power to outlets. So we can run our computers and crap without the generator. There we go. So stay tuned. Jeff is going to be explaining and doing all the how-to with this whole situation.
Alright, so today we're going to replace our broken inverter. As I may have mentioned previously, we've got an inverter in here that died shortly after we bought the RV. It's a 1,000 watt inverter that was used primarily to power the refrigerator. In fact, that's the only thing it powers right now. And when I replace this one, I'm going to replace it with a 2,000 watt inverter that we're going to use to power other things. Today we're just going to get it up and running on the refrigerator and make sure everything works. And then in the future I'm going to run another circuit breaker or two so we can run our outlets in the coach without having to run our generator. So to start with, we're going to go ahead and disconnect power, remove the old one, and then look at mounting the new one, disconnect power, and run our power to the refrigerator. So the first thing we're going to do is go over here and disconnect power. This particular inverter was just plugged into an outlet. Our new inverter is not going to be plugged into an outlet. We're actually going to hardwire it in. But I've unplugged it from AC power. I've also secured power at the breaker. And now we got to go ahead and disconnect the battery from it. Once we disconnect the battery from it, we can finish disconnecting everything, pull this out of here, put the new one in there, make sure it fits, and start attaching wires. Another point here, these wires are kind of small for a 2,000 watt inverter, so these will be going away. We'll add new wires in here. In the future we may add a new bus bar fuse for it, but right now we're just going to use the current one because we're not really requiring too much of it. So these wires are going to go away. These wires, which are significantly bigger, are going to replace them. These wires will make sure that you have a low voltage drop between the battery and the inverter so that the inverter gets the maximum amount of DC voltage. If you don't know what you're doing, and even if you do know what you're doing with electricity, you can purchase one of these for $15 at Walmart or $20 depending on the quality that you get. Highly recommend you take your voltmeter and check your AC voltage, which we've already done. Check your DC voltage when you're disconnected to make sure you don't get shocked. Always use a multimeter to check your outlets, check your power before you touch it because nobody likes getting shocked. So without further ado, I'm going to go ahead and pull this out, and then once I get it pulled out, we'll go ahead and look at installing the new inverter. So point this out. Feel me? Alright, so we've disconnected our DC power, battery power. We've disconnected our load from it. We've disconnected the DC monitoring circuitry for it because it monitors and switches over automatically. And as previously pointed out, we disconnected our AC input. So now what we're going to do is just pull this one out. And as you can see, I've already kind of been at this. When I troubleshot it, it was already loose. In fact, you can see the covers loose. This is what actually does the bulk of the work. This is the control circuitry. Something in here is burnt up and it goes straight into overload, and it's not really worth troubleshooting and repairing because it doesn't do what we want to do, and the cost to fix it will be a little bit higher than I want to spend on it. And I was planning on upgrading anyway. So our new unit is right here. This one has already been set. A couple things about this one is we've got our AC input and output on the front. Are you recording that?
Yeah.
Okay.
Yes!
AC input and output on the front. We've got an outlet up here, which is what we'll primarily use until we actually wire in another circuit breaker. And then on the back, you've got your terminal lugs for your DC input. You've got some dip switches over here. that allow you to specify low power and whether it supplies power preferentially to the to your AC power or gives preference to keeping your battery. You've got a battery temperature sensor you can plug into it, and you've got an auto start for your generator if you've got a generator that'll do that. On the top, you can select the type of battery that you've got, and it's got its status lights here, so you can actually select different charging voltages, which is kind of nice. I don't know how accurate it'll be. We'll have to investigate that while we're doing it, but you can tune your inverter to the battery that is going to be charging. So we're going to go ahead and put it up there, see if it fits, and then proceed with wiring it.
Okay.
So as you can see, we've got a problem here. Our bigger wire does not fit through the holes that are there, so we're going to go ahead and have to put some new holes in there. In order to protect them, I had to run to the hardware store and get something to protect the wire going through there. If you don't put something in there like a grommet or a pass-through, what will happen is as you're driving down the road, that sheet metal is going to cut your wire, short it out, and probably burn your coach down. So probably want to do something to protect it. Now, the hardware store that's right down the road didn't have any grommets big enough for this, so I'm going to have to hack together something. What I'm going to do is take some PVC couplers that are big enough and use some flat nuts, and I'm going to put one on each side, and this is going to suffice until I can find some actual grommets later on and replace it. But for now, this is going to work great because it provides a nice smooth surface on the inside that won't cut the wire. So I'm going to drill a couple holes, put these in there, and then run the wire through. Hole saw, great for cutting holes in sheet metal. One hole down.
It's kind of hard to get a good angle.
Two holes down. So now what we're going to do, put one of these through there on each one. Thread your flat nut on there, so however far you want it. Shove it through, and then go over to the other side and tighten it down with the other flat nut. Get the grommets, pass-throughs in there. You're going to feed your wire through and just kind of mount it or rest it close to where the terminal is, but don't hook it up yet because you still got some wiring to do, and you don't want to be shocking yourself with it. So run it through, set it there. Make sure it's not going to hit anything, any of the terminals or anything. But get it to an approximate length so that when you go back to hook it up later, it'll be right there for you. Alright, so we've ran this ground cable through and put terminal on it. We've ran the power cable through, put terminal on it, hooked up the fuse block, created another cable to connect to the back of the inverter for the DC input. Also, along the way, I had to move this ground wire because it was up in the front initially, and this current inverter that we're putting in requires it in the back, so I moved the ground wire back here. And I also rerouted the load wire for the AC. I didn't like it coming over here on the left hand side where it was in the way of cargo and stuff, so I'm rerouting it on the other side. Now what we're going to do is take the AC from the outlet up here that the other inverter was plugged into. If you look up here, there's an outlet up there, and we have to have some type of supply, and right now that's the supply I'm going to use. It's a dedicated 15 amp circuit, so that's enough power to supply the outlets and the refrigerator in the RV because that's all they're on. So what we're going to do is we're going to take that and use that as a supply. In the future we may, as I mentioned earlier, put another circuit breaker in and kind of branch out our wiring and expand it a little bit, but for now all I'm trying to do is make sure that our refrigerator is up and running for our upcoming trip. All the outlets and everything else is going to be future. So we're going to go ahead and take this outlet off here, and again, make sure you've got power to it, otherwise you might get shocked. if you spend some time working on an RV, it'll never cease to amaze you just how cheap and flimsy this stuff in the RV is. For instance, this outlet, I don't know what's going on here, but I'm just going to cut the wires to it instead of trying to pull it apart while it's over there in the hole. You see, the screws didn't really come out very far, so it's hard to take apart, so that's why I cut the wire. I will probably save it for reuse if I ever want to put an outlet there again, but for now, the important thing is I want this AC power. Alright, so here we are. We've got the ground connected, we've got the hot wire connected, we've got the other ground wire connected to ground at the chassis. So we put the covers on it to cover it and protect it from hitting some metal. So now it's time to go ahead and mount it up here, and then we need to connect the AC power. If you look up here, we've run the hot through a 50, that's 150 amp fuse, which should be plenty for what we're utilizing it for. And again, the wire's going through the pass-through. Alright, so here it is installed. We reinforced it a little bit so that it wouldn't overwhelm the little platform that was on. But if you look at the lights, you can see that it's actually charging and it's on shore power and it's doing what it needs to do. It actually senses the shore power, it's charging, it's outputting AC, it's working properly. We did have one moment, actually it was a little bit more than a moment, where it wasn't working. The reason why it wasn't working is because we had a dip switch set incorrectly, so it wasn't sensing the AC and working as a charger, it was working as a pure inverter. So we flipped the dip switch setting after somebody helped us out on Facebook, and now it's all good. Alright, so we had a moment when we first plugged it in and tried to get it to work that the inverter was only working in pure inverter mode. It wasn't sensing the AC, it wasn't passing through AC. It took a little bit to figure out what was wrong, and it was a dip switch setting that was wrong. This dip switch was set to be preferential on battery instead of AC. Once I flipped that switch, I started charging the battery, it started doing pass-through AC, and it works properly. It comes over to inverter when the AC power is cut off, and everything is working good now. So there you have an Ames 2000 watt inverter install. This is pretty easy install because there was already wires here, but you just have to run a couple wires if you don't have wires already. There you have it.
Alright guys, well that was how to install the inverter. Got any questions? Ask Jeff, not me. Directly. I hope you enjoyed seeing how to install a new or a different inverter in your RV. Got any questions? Hit us up. Thank you for watching. We'll see you next time.